Hey everyone, I just wanted to go over a couple of things with you about the trigonometry and a given point. So we know that we have certain points that we'll refer to as any given angle, and certain points that fall with a terminal ray that intersects a circle. Okay, so we have these points, and of course we have the r value, right? We all know how to find that r value right here. Okay, and we've already been familiar with the sine formula, with the cosine formula, and with the tangent formula right there. One of the things we really haven't talked about is the reciprocal identities. So the cosecant of an angle is always going to be the reciprocal of the sine, and the secant of an angle is always going to be the reciprocal of the cosine. And the cotangent is always going to be the reciprocal of the tangent. And so it's no surprise that we see here that the formula for cosecant of theta is just the flipped version of this, right? So that would be r over y. And then the secant of theta would be r over x. And then the cotangent of theta is x over y. Okay, so that's what we're going to be seeing here. And I just wanted to do a little side piece on that. Okay, so let's take this point and let's find the six trig functions. So we are all familiar with how to find the sine and the cosine and the tangent. We at this point, we know that it's not one of our common angles on the unit circle. And so in order to find r, we're going to do the square root of x squared. So negative 3 squared is 9, plus negative 5 squared, which is 25. And this gives us the square root of 34. And that's the r value. Now, if we're going to take sine of theta, all right, then we're going to get y over r. So we get negative 5, that's the y value, and r is radical 34. All right, now we're going to rationalize this by multiplying radical 34 to both parts of the fraction here, and that'll just give us negative 5 radical 34 over 34. Remember, no radicals on the bottom. Okay, so that's our sine value. Now keep in mind that we set it up right there, right, with y over r, but we didn't want to leave r on the bottom. So if I had to do the cosecant, remember I'm just flipping my setup, and that would be r over y. So that would be the r value over y, which is negative 5, and that's that right there. You see? All right. Okay, so if we had to take the cosine of theta, then we would be doing x over r. And so x value here is negative 3. R value is radical 34, same thing as before. We're going to rationalize, so multiplying radical 34. And we end up with negative 3 radical 34 over 34. And we leave it just like that. Alrighty. And then we have our secant of theta, which would of course be the reciprocal of the cosine. And so that's going to be radical 34 over negative 3. Notice I don't flip this. Because if I was to flip this, I would get that radical on the bottom and I have to do all this work again. So let's work smart, not hard. All right, last one missing here, tangent of theta, right? So that's y over x. Negative over negative is positive, so that's just going to be 5 over 3. And the reciprocal is cotangent of theta. Flip that around, 3 over 5. Alrighty, so we got our 6 trig functions right there. And that's how we work out those formulas. You should know this for your 3A test. All students take calculus. When we say all, we mean that all the functions are positive in this quadrant because the x's and the y's are positive. In this quadrant here, sine and of course cosecant, that's a reciprocal, but let's focus on sine, right? Sine is going to be positive in quadrant 2, and that, think of your S there for sine. T stands for tangent, right? All students take calculus. T stands for tangent, and its reciprocal cotangent, positive there in quadrant 3. And C stands for cosine, and its reciprocal secant, right? But again, let's focus on the original 3, sine, cosine, and tangent, okay? If I tell you that there's an angle, and it falls in some quadrant, let's name the quadrant. We know that tangent is going to be less than 0, and that really just means the tangent of the angle is going to be a negative value, and cosine of theta is greater than 0, and that just means that cosine is going to be a positive value. And think about what cosine is. When we see cosine, we should be thinking, hey, I know that that's x. X is going to be greater than 0. Whoa, okay, well, where is x greater than 0? X is greater than 0 in these two quadrants right here, right? And then where is tangent negative? Well, if we keep in mind that all students take calculus, we know that tangent is positive here and that all functions are positive here. So we want both of these conditions to be met. All right, so tangent is positive here and tangent is positive here. Where is it negative? Well, it's negative in this quadrant here, and it's negative in this quadrant here, all right? And again, we want both of the conditions to be met. And if both conditions are to be met, here we have cosine that's positive, and we have tangent that's negative. And so we're actually going to go with quadrant 4, all righty? This next question could be kind of difficult. And let's just say that we didn't have the graph given to us, right? Let's just say that they told us that tangent of theta is negative 2/3. Well, where does that negative go, right? If we know that tangent is y over x, does the negative go with the y? Does it go with the x? Does it really matter? And truth be told, it really does matter, okay? It matters because when you had to find other trig functions, like for example, say we had to find cosine, we know that cosine is x over r. If we apply a negative there and it's supposed to be positive, that would make that answer incorrect. Okay, so let's keep that in mind. Well, let's keep reading, right? We know that tangent is negative 2/3, and we know that cosine is greater than 0. Well, what is cosine? We talked about it up here. Cosine is x, right? And x is supposed to be greater than 0 here. Well, that tells me that x is positive. Just like this last example, x is positive in this whole region up here. Everything on the right side of that y-axis. That's where x's are positive. So if we get a tangent value that's negative, keep in mind all students take calculus, just like before. Doesn't that mean that tangent's negative in this quadrant and in this quadrant? Yeah, right? So where are both of these things happening? They're happening here again in quadrant 4. So this example was really just to prepare us for this one, right? And that means that we have this. Okay, so now where does that negative really go? Well, we know that if tangent is y over x, this here is the x-axis, and these x's happen to be positive on this side of the x-axis. But what happens to these y's on the y-axis? Well, these y's are really negative. And so which one of our values is actually going to be negative? And it turns out that with this coordinate right here, x is positive, and it looks like y is negative. Okay, so that's how we come up with this coordinate, 3 and negative 2. Could you have accidentally put negative 3 and positive 2? Yeah, and had you done that, you would have ended up over here in this quadrant, all right, which would have been a mistake because then cosine is actually it's less than 0, not greater than 0. Okay, so we got to be careful with that. This is one of the most difficult types of questions that we see. Anyway, just to speed things up, I'm going to give you the r value right there. And so if we had to find cosine of theta is x over r, and so we can say that x is 3 over radical 13. Let's rationalize. So we multiply radical 13, and we end up with 3 radical 13 over 13. And if we had to find cosecant is the reciprocal of sine, so it should be r over y, and that's going to be radical 13 over negative 2. Now, students ask me this all the time. Where do I put that negative? Do I put it on the bottom? Do I put it on the top? Do I put it in the front like the question here? The negative just has to get applied to the fraction. Honestly, I just put it in front of the 2 because the number was negative 2. As long as it's on your fraction, I'm a happy camper. Okay, let's keep going. And let's talk about the unit circle. We can fill in all these values, right? For sine, for cosine, and so forth. And eventually, hopefully, I hope you know how to fill out tangent. So how did I have you memorize that this year? We made those quarter circles, right? We had a quarter circle with some common angles. That was our pi over 6. That was our pi over 4. Pi over 3, right? And then up here, we know that's pi over 2. All right, this is, of course, 0, and all the way back around the circle to 2 pi. Okay, so those are points as well, right? These points on the circle were 1, 0, and this one here was 0, 1, if you recall, because this was the origin, right? 0, 0. So we did a little counting rule, right? We go from 0, and since everything is a square root of something over 2, how do we go from 0 to 1? Well, we just count up. So we'll square root of 1 over 2, square root of 2 over 2, right? Square root of 3 over 2. And then this one comes from the square root of 4 over 2. And then we go the other way and count up. So from 0, we count up square root of 1 over 2, square root of 2 over 2, square root of 3 over 2. And again, this one just comes from the square root of 4 over 2. And just like that, we got our first quadrant. And remember, the whole unit circle is symmetrical. All right, so we're going to use that now to answer a couple of questions. So if we had to do a tangent of pi over 6, we would be doing y over x. Remember, the tangent is always y over x. So let's do a little scratch work here. Let's start with tangent of pi over 6. So that's going to be y over x. Keep change flip, so change it to multiplication. Flip the x, so that's 2 over radical 3. These are going to cancel. And I'm going to rationalize as well. So that's going to give me times radical 3 times radical 3. And let's see, we get 1 times radical 3. That's just radical 3. And on the bottom here, we just get a 3. Okay, so that's what tangent of pi over 6 is. What about tangent of pi over 4? Well, if I were to take square root of 2 over 2, change this multiplication, and flip this around, so 2 over radical 2, doesn't everything just kind of cancel? Oops, 2, I'm sorry. Doesn't everything just cancel out? Yeah, right? And so that's why we get 1. And then the last one here, y over x, so we're going to do radical 3 over 2, change that to multiplication, flip that around, so that's 2 over 1, and then these will cancel, and we just get radical 3. Alrighty, so that's our tangent values. You should know how to obtain them. And remember, we refer to tangent a lot of the times as the slope of the terminal rays, so the slope of this thing here, okay? All right, let's talk about reference angles. So those are the common angles, but if you see an angle that's like 5 pi over 6, your reference angle is pi over 6. Or if you see an angle that's 4 pi over 3, your reference angle is pi over 3. And so we'll use that combined with all students take calculus to piece everything together. So let's use this one here. So here's 5 pi over 6 coincidentally, right? So we know that the reference angle is going to be pi over 6. Hey, what is pi? Pi over 6. Then we can use that to find the cosine, the sine, because we know those. We'll eventually know those by heart, right? So the reference angle is pi over 6, okay? And then 2.5. When you see 2.5 here, where is 2.5? So remember that this is 3.14 because that's pi. And this is pi over 2, right? But pi over 2 as a decimal is about 1.57. So if I had to figure out where was 2.5, I would say it's somewhere in here in this quadrant there, okay? Now the formula for a reference angle is that you would technically take pi and subtract 2.5. We're not going to see questions like that on the AP exam, so we can leave this question out, okay? But just so you guys understand, where does 2.5 fall? Somewhere between 1.57 and 3.14. Okay, so let's try to see if we can get to this question here. All right, so this is a cosine of 4 pi over 3. 4 pi over 3. So we know that the reference angle is going to be pi over 3. All right, so now I want you to calculate the cosine of pi over 3. So let's go back to that little quarter circle that we did, right? Because we're probably going to use that a bunch of times once we create it. So the cosine of pi over 3 is the x value of pi over 3, right? That's 1/2. Okay, so since we know that that's 1/2, cosine of pi over 3 is 1/2. Okay, perfect. However, that was of course in quadrant 1. But cosine of 4 pi over 3 isn't there, is it? So this would be 1 pi over 3. This over here is 2 pi over 3. This over here is 3 pi over 3. And this over here is 4 pi over 3. We really have an angle that's in this quadrant instead. Okay, so we just put our answer together, 1/2, with all students take calculus and figure this out. Is cosine going to be positive or negative in quadrant 3? Because that's where our angle is located. And it turns out that the only thing positive down there is tangent. So we're just going to throw a negative in front of our answer and say that that's the value of cosine of 4 pi over 3. And it is that easy, okay? All right, I'm going to put some questions regarding this lesson. Hope it was helpful.